the product of the number of hazard causes and the number of hazard effects. That's to say, if there's 10 possible things that could go wrong and 5 possible bad things that could happen, then you have on the order of 50 parameters to be specified, making all kinds of simplifying assumptions to get to that number. So the point I'd like to make in this first challenge, why I call this computational, is that model complexity measured, for example, in terms of this number of model parameters, it should be a focus almost on equal footing with the desire and the need to develop models that are accurate. So this is just a really hard part of modeling in the UAS space for risk assessment. And then there's, of course, this natural question. How do you assess whether or not your model is any good? How do you know that the model you've made is not too simple, right? Simplest models are completely inaccurate. And I think there's many answers to that question. One of the ways that we framed it on the A21 project was, well, does the use of the model lead to judicious decisions in this context of go, no go for BV loss ConOps? And making an assessment of how well you did on that criterion is an important component, I think, of ongoing and future research. All right, let's move on to the second challenge. So let's suppose that you navigated that first challenge, that computational challenge, and now you have a model that is both accurate and computable. So this is a admittedly confusing figure, so I just want to spend a minute or two explaining what you're looking at here. This is a map, an overhead view of a hypothetical situation in which you see a yellow line. I'm just going to, all 9 of the figures are very much related, so just focus on one of them. You see a yellow line, kind of a parabolic shape. That's a target path for a UAS. And the green and the blue regions, the green region above and the blue region below, just think of those as heavily populated regions. And so you think of the white strip as a road, a bend in the road, and our intention is to navigate a UAS along that yellow line as the target path. Well, the only difficulty that we're facing in this simulation setup is that we're facing some wind. And the magnitude and direction of the wind is shown, and may not be very visible to you, but it's a little bitty arrow in the top right corner of each of the 9 figures. So in the left figures, the wind is blowing to the northwest. In the middle column of figures, it's blowing to the southwest, and in the right row of figures, it's blowing to the east. In the top row, the wind is light. In the middle row, the wind is a little bit more heavy. In the bottom row, the wind is rather strong. So the control model here is very, very simple. If the drone is near to its target path, then it kind of continues along the path. And if the drone gets away from the path, then it turns towards the path and heads back in. Right, so it's a very, very simplified and simplistic model. Real systems are much more complex than this. But the point of this simple model is the following. The goal of the trajectory, as you see, is to get to kind of the lower right-hand corner of the screen of the figure in all 9 cases. And the different trajectories under the different wind environments show that when the wind is light and even when the wind is moderate, the drone is successfully able to navigate the wind and overcome it. In the bottom panel, however, what you see is something a little bit different. When the wind blows to the northwest in the lower left corner, what you see is that the drone ends up stalling. It ends up trying to face back towards the path that it is trying to get back onto, which is directly contrary to the direction of the wind, and ends up just stalled and unable to move forward. In the bottom center panel, you see that the drone is trying to fight the wind, which is blowing it away from its target, and it ends up completely off target. Whereas when the wind is blowing to the east, it's able to navigate and get to its intended destination. So I'm not sure if that all made sense, but the point is really just this. What I mean by an environmental modeling challenge is even when you have a very parsimonious model, one of the things that's very difficult about probabilistic risk assessment for UAS is the fact that you're not likely to have a solid knowledge of the distribution on unknown environmental factors in advance of the ConOps time. So if you're trying to make a go, no-go decision and you don't know the wind and you don't know the distribution of the wind, it's going to be very difficult for you to know the distribution on the possible hazard effects of the ConOps. And without that, it's very hard to do risk assessment at all. So I think this is an ongoing challenge in this space, and one that I think all the frameworks are trying to deal with in different ways. With my last third challenge, my last slide, turn to a third challenge, which I call the coordination challenge. This one's a little bit different than the first two. What I mean by coordination challenge is, in this context, two different things. That it is both important to and difficult to have large-scale systematic data collection in the context of UASs for purpose of probabilistic risk assessment. And it is both important to and difficult to have model integration and alignment across all the different measurements to have unified statistical models. So let me kind of explain and unpack what I mean by those statements. So the first case, we're talking about systematic data collection. None of this is particularly technical or novel. It's pretty obvious when you think about it. And if you worked on data collection, it probably resonates. But there's real problems with participation incentivization, especially when we're talking about data that might be sensitive and held closely in the hands of competing industrial partners. Data taxonomization, how do you accurately and meaningfully and insightfully describe the data you've collected and are willing to share in a way that will be profitably used by others. You have real concerns with data security, both in terms of the confidentiality, integrity, and availability, and naturally concerns about data privacy. So nothing here is particularly not obvious or sophisticated, but it's a real challenge. Now, why do you want to do this in the first place? Well, I think that what you want to be able to do in the end is ultimately be able to integrate data from many different ConOps over many different settings in many different environments with many different platforms, and have a way of leveraging those different measurements, those different instances into overall statistical models that inform the parameters that are going to be essential to any type of probabilistic risk assessment scenario or simulator. And why must we have that? Well, I think that the motivating need comes from the great example in insurance, where they're talking about mortality insurance or car insurance, home insurance. You know, the success of the insurance industry over decades and centuries has been that they've identified what are the well-chosen statistical models that extract the relevant factors from making judicious decisions regarding claims and pricing and everything like that. And then also having voluminous and extensive and verified data to inform those models. And my assessment is that with regard to probabilistic risk assessment for UAS, we're at the very beginning steps of that. We haven't solved this data coordination problem, and we haven't solved this integration and alignment problem. So I think both of those are aspects that are called coordination challenge on top of the other two challenges I mentioned, being computational and environmental. So that's, I think, it's probably about 10 minutes, and that's probably the remarks I would want to make for now, and I will turn it back to Lux. Thank you.
Thank you, Dr. Weber. And everybody's reminded to put any questions that their comments that they have into the Q&A for Dr. Weber or Ricker, who's up next. Kyle serves as a research engineer and technical lead for Mississippi State's Rapid Flight Research Laboratory. Kyle currently leads the execution of several federally and commercially sponsored projects related to advanced UAS operations for Group 1 through Group 5 UAS. This entails the integration of SORA and other risk management techniques in the development of complex safety cases unique to each operation, spanning electrical infrastructure inspection to search and rescue over water. So over to you, Kyle. Look forward to your words.
Thanks, Lux. And Dr. Weber, I think my talking points will be really complementary to the PRA that you went through. So just quick additional background that's probably relevant to this discussion and the webinar as a whole. So I'm Kyle Riker. I'm a research engineer at Mississippi State. I recently got my master's in a thesis that you actually can see, and I don't have the mirrored video, but you can see the thesis work that I did to integrate 3 flat panel radars into a large Group 3 UAS. That had all sorts of different technical challenges, all sorts of risk management challenges, And one thing that got often brought up was from the FAA side of things. So here being under the regulatory framework of the FAA is safety management and safety risk management. One of the hardest kind of the pain points, and I'll get to that here once I get to that point in my notes, but one of the pain points historically with the SORA process was that it sort of dulled in comparison in its younger days, and I'm talking 4 or 5 years ago, sort of dulled in comparison to the tens and the decades and decades of FAA existing safety management processes. And so it started off a little bit rough to be accepted as a means of safety risk management in the United States. Since then, we've seen all sorts of authorities across the world start to accept it because it does, in its most current form, version 2.5, if you're not familiar with that, it should be accessible on the internet. In its most current form, it's gone through several iterations. It's no longer this new, young process with a lot of leniency was one of the predominant concerns. So it was just recently got published with new appendices and annexes in the back of the document, with some more quantitative thinking, kind of guidelines for thinking through some of the things that you would experience with trying to develop a safety case for a drone beyond visual line of sight, typically what the process is used for. But along those lines, there's all sorts of tools out there that are accessible. One thing I would strongly encourage is regulatory participation and industry participation from the Australia regions in some of the international standards. So I'm co-chair for the ASTM International Test Methods, which is a group that's trying to figure out how to appropriately test small drones detect and avoid systems. So we're not in the world of RTCA or the FAA standard processes where we're trying to do thousands of flight hours of validation. We're really concerned with getting to the bottom of the problem as quickly as possible and as affordably as possible. And so hopefully some of my discussion points today will bring some insight from that group as well. But just jumping into the SORA process itself, and what I think would be relevant from the pain point side of things for this discussion. As I mentioned, there's initially some back and forth with the FAA. Since then, we're starting to see international civil aviation authorities start to accept the SORA along with different already existing domestic safety risk management processes specific to their countries. You know, the SMS that exists in the United States is it's a great process. It's tried and proven. But the big question is, what is the level of appropriateness for a small drone, or if you're a company like Google, or trying to do multiple small drones in a small confined space, what's the applicability? So in 2020, Mississippi State started going through some research on the SORA process. Primarily, we wanted to look at what are the sticking points that maybe one, confuse the end user. So how does an operator or an integrator interpret what's being told to them through the SORA process itself? And in my opinion, that has becoming increasingly more clear with the latest version 2.5. So all the props and due respect to the folks who meet the JARIS group that meets several times a year for plenary sessions. So in 2020, we started looking at the process for beyond visual line of sight operations, specifically, which may be of interest to this group, specifically for first responder applications. We've been developing over the last 4 or 5 years modeling and simulation tools to try to quantify things that maybe aren't super clear as to what those upper and lower bounds are in the SORA process. So one thing that comes quickly to mind is population density. How do you analyze your population density? Is it Census Bureau data that we might have in the United States? What is the applicability of that data? What are the limits to that data? All these sorts of things start to get brought up when you try to use the SORA process. And if you don't have really strong data-driven answers, then you have to lean on industry expertise and precedent where you can. And so groups like ASTM and RTCA that are, collaborating with industry expertise, as well as JARIS itself, being a collection of academics and industry partners, they're trying to streamline some of the quantification efforts. So it would not be good business of me and being an Assure researcher to not mention some of the efforts that we've actually been looking at and performing some research over the years for answering the exact question that I posed. Because what often happens in safety risk management when it's applied to an operation by an operator or a systems integrator or some collection of those stakeholders, we start to get into a little bit of a rabbit hole with debating on whether something is 10 to the minus 9 probability, or is it 10 to minus 3, or some range in between. And if you don't have a really great data set of tens of thousands of hours of flight data that somebody like a Boeing or Airbus might have, there really isn't a great way to look at that or to really justify the numbers that you choose. So one area of research that Assure is actively engaged in is looking at the quantification of some of the aspects, not specifically the SORA process, but just safety risk management in general, which could be applied and leaned on by the international CAAs that are already leveraging the existing SORA process. So I'll talk about a couple different things. I apologize, I don't have slides. There's a lot of cool pictures and stuff that you can see on assureuas.org. If you go in there and dig around, you can find all the different research reports that have come out, but I'll try to highlight just some of the main ones that I think could be leveraged when it comes to integrating SORA into an existing regulatory framework. So first one, let's see, looking at quantification for various risks associated with shielded operations. So operations near power lines or where manned aircraft generally do not want to fly just due to their own self-serving interest to be safe in the national airspace. And so there's some Assure research that is wrapping up related to what are the expected electromagnetic interference risks and things like that. Another really big question that there hasn't been a lot of pointed specific research targeted in the small UAS sector is the human factors requirements. Admittedly, some of the international standards do not have human factor requirements that are really rooted in any sort of data-driven way. And so a project that's been going on since, I believe, 2021 and wrapping up this year is looking at, okay, so what should the human factors be when it comes to things like clutter and interrupting the operator's normal procedures, and looking at those corner cases for what if we have residual clutter from like a radar system. So that research is wrapping up here through Assure. You'll be able to get access to the report. Another one that, of course, is a little bit closer and dear to me is the massive amount of work that we've been doing on quantifying what is the current level of safety of the national airspace when it comes to general aviation. So one thing I'll preface with is I've always been under the opinion that a pilot flying a Cessna 172 in Class G or just very rural airspace is probably flying very similarly, whether they're in the United States, whether they're in Australia or somewhere else in the world, assuming your geographies are relatively similar. There's not going to be a major difference in how well they can specifically see other aircraft and perform the necessary avoidance to safely operate. So since 2020, we've put 128, was the final count, 128 general aviation pilots through a series of different tests just to quantify what is the current level of safety that the UAS industry needs to meet. For the SORA process, that's really important because that plays into your air risk classes, which naturally play into your ground risk classes. And so we've gone through this extensive effort to measure over 120 pilots just to see, well, if we're going to use a term like a risk ratio, which doesn't necessarily always translate to the SORA process, but it can be used to maybe validate your DAA system, which is your primary means of detecting and avoiding. And so, several pilots into that research, we now have suggestions that will be reported on later this year. There is already an existing report from a smaller subsample of pilots that exists on the Assure website that hopefully, what I'm getting at with these talking points is hopefully we are able to leverage some previous research to really ease some of the implementation of the SORA with the Australia folks. Lux, I see you jumping on. Am I at my limit? So yeah, I'll just do a quick summary. all sorts of research going on. I would strongly recommend industry, academia, regulators get together, talk through some of the quantification that would be needed to get the confidence that you need in implementing the SORA process for your use case, for, as mentioned in the invite, for the unique geographies that you see in Australia and some of the unique regulatory framework that already exist. Lex, I will kick it back to you, or I believe next on the is Jackie.
Thanks, Kyle.
Hi, Jackie. I'm trying to bring my video back, but I'm unable to. There we go. Thanks very much, Carl. So next, I'd first of all, before we go on to our own CASA presentation, I'd like to thank Carl and the Assure team. I'm delighted to introduce Rowan Kimber. Rowan is the Senior Standards Officer within RPAS Policy and Regulation at the Civil Aviation Authority in Australia. Rowan will be sharing a presentation with Australian perspectives. Over to Rowan.
Great, thanks, Leanne. I'll just share my screen.
Cool.
Okay. So I'd like to start by extending a warm welcome to everyone for attending. Thanks for taking the time. As Jacqueline said, my name is Rowan Kimber. I'm part of the team at the Civil Aviation Safety Authority in Australia that's responsible for developing policy and regulation related to remotely piloted aircraft systems. Before we delve into the heart of our discussion, I'd just like to join Leanne in acknowledging the traditional custodians of the land. The profound wisdom and rich traditions of First Nations cultures remind us of the significance of learning from the land, each other, and our shared experiences. We gather here today in the spirit of learning and growth, acknowledging that knowledge is a journey we embark on together. I'm thrilled to share CASA's journey with Beyond Visual Line of Sight drone operations. Initially, I plan to discuss how the JARAS Specific Operational Risk Assessment, or SORA, enabled the Australian RPAS industry to overcome the visual line of sight barrier. However, upon further reflection, I realised that SORA is just one piece of the puzzle in enabling BVLOS operations in Australia. You see, BVLOS in Australia is actually not a new thing. Speaking to colleagues in CASA's RPAS Regulatory Oversight Division, I got first-hand accounts of BVLOS operations in Australia at altitudes of up to 20,000 feet commencing in the mid-1990s, long before the introduction of SORA. Like all nations, Australia's approach to RPAS regulation is a product of history, geography, and culture, just to name a few. We're a really big country with, on a global perspective, very few people. In the early days of uncrewed aircraft, this facilitated the safe testing of novel technologies, trading off reliability for the likelihood of impacting a person due to our sparse population. Sound familiar? As RPAS technology became more commercially capable, Australia took the bold step to try and facilitate the expansion of RPA operations in a safe manner by the introduction of a remote pilot licensing and RPA operator certification system, and it's come through different names over time. This was a novel concept at the time, and over the past 20 years or so, it's developed into a valuable tool in ensuring safe RPA operations. In 2017, Australia overhauled the remote pilot licensing and operator certification system to add further rigour around it. Last year, we expanded the remote pilot license concept to add testing for the knowledge components needed to conduct safe BVLOS operations, known as the BVLOS OCTA exam. By setting rigorous training and testing standards under the remote pilot licensing system and assessing and approving the organisation not for a particular operation, but as competent to operate commercially, CASA created a guaranteed minimum standard that could be leveraged to enable complex operations for many years. This competence guarantee was a primary mechanism for enabling early BVLOS operations. Improvements in technology sparked greater interest in uncrewed aircraft operations in general, and in particular BVLOS operations. And as good as our system of pilot operating certification is, and I genuinely believe that, it was not initially designed to handle the BVLOS aspirations we see today. And by the mid-2010s, it became apparent that more focus was needed on demonstrating how BVLOS operations meet an acceptable safety standard. Australian regulations empower CASA to approve an operator to operate outside of visual line of sight, where it determines that the operations do not have an adverse effect on aviation safety. And for Australia, this is where SORA now comes in. Today, SORA is the preferred methodology chosen by CASA for the assessment of most BVLOS concept of operations. And I say most, there are some fringe cases that sit outside of it. Unlike some nations, CASA has not enshrined SORA into our regulations. In theory, an operator can choose to use any risk methodology to determine that their operations are safe. In practice, though, the use of SORA streamlines the assessment process and provides a common language between the regulator and the operator, such that now it's often the most sensible option. This is the case not just for BVLOS operations, but for any complex operations that the SORA methodology is designed to handle. We see it in Australia for the approval of remotely piloted flight testing of AAM platforms, and where we're using RPA operations in larger platforms to operate over people. SORA has not replaced our pilot and operator certification system though. In Australia, they work hand in hand, with the outputs of our certification system being inputs to SORA. And that results in all of our 3,000 odd certified operators in Australia meeting or exceeding the majority of the training and competency operational safety objectives under SORA to a SAIL 3 and in many cases a SAIL 4 level. We're presently using SORA 2.0 in Australia in its native format. Our ability to use the model unaltered stems from Australia's heavy involvement with JARIS. As a nation, we're fortunate to have some of the world's best air and ground risk minds, and these people have consistently advocated within JARIS for the Australian perspective when developing SORA. The result is a SORA which has been extensively fit for purpose. So you can see the photo there. That's the most recent JARIS plenary in Astana in Kazakhstan that was earlier this month. The photo in the corner is the Australian contingent of industry and regulators that went to that meeting. So you can see in the grand scheme of everyone that's there, we held our own and quite proud of Australia for our work that we do within the SORA. Everything I've said about SORA though, it's true to say that it's not without issues in Australia. As I mentioned, we have a big country. We don't have many people. And that actually creates some issues. One of the major issues we get is that we have a lack of data, the data that we need to leverage the quantitative elements of SORA. Related to the lack of data is the fact that we have a significant number of crewed aircraft in Australia that are not equipped with electronic transpurity devices. Not only does this impact our ability to correctly categorise initial air risks, but it also impacts the ability for BVLOS operators to meet the detection component of the SORA tactical mitigation performance requirements. Our application of SORA is also not entirely consistent with other nations. Whilst we follow the model, there have historically been key differences in the way we approach the criteria. One classic example is the way in which we approach the M1 ground risk mitigator, as far as Australian operators do at least. Where we see in European nations, an initial area is carved out from any higher population density, and so the initial ground risk is based on a lower population. In Australia, we find applicants choose to include an entire area and then use the M1 ground mitigator to carve out the area. And this is largely due to the fact that we have such large areas as part of our BVLOS operation, again, due to the size of our country. Ultimately, it doesn't make any difference which approach you take. But it's interesting what differences in geography and access to data has on the application of SORA. SORA 2.5 is set to resolve some of these issues. And that photo is from the adoption vote of SORA 2.5. It was a big moment for JARIS. It was a real privilege to get to be in the room for that. Just like its predecessors, Australia has punched well above its weight in relation to contribution to the updated model, and both CASA and experts from Australian academia and industry have worked hard to ensure, as best as possible, that the model is fit for Australian purposes. Australia was a strong advocate to increase the granularity in the population densities under the updated ground risk model and the inclusion of the qualitative descriptors for the new population density bands. If you haven't had a look at it, it should be released on the JARIS website in the next couple of days, and it's worth having a look. It did take some work convincing other members of JARIS's Safety and Risk Management Working Group, the group responsible for the SORA, that there really was a use case for 5 and for 50 people per square kilometre population bands. I did try to have the model include even lower population bands, going right down to 0.5. But I think the other members of the working group thought I was joking when I said that 5 people per kilometre in Australia could be considered highly populated in many areas. CAS has commenced work on the implementation of the updated methodology, although we've still got some work to do before we move away from SORA 2.0, and we'll provide more information in due course. So what does the future look like? Well, first up, it's worth noting that our pilot and operator certification construct is a reasonable departure from the JARIS Open Specific Certified construct. And at this point, we're comfortable with the difference. While we'll continue to consider international practice in the development of our regulations, and we do so as a matter of course, as it currently stands, our system provides CASA with the flexibility to provide general approval for operations that would not be appropriate under the open category. This is particularly important as we better understand the risks posed by RPA operations. We leverage the SORA and are able to enact new approvals to broaden the scope of what can be done in Australia. As to the use of SORA, well, at this stage, it remains CASA's preferred risk assessment methodology for BVLOS operations. Probably the biggest change we're likely to see in BVLOS operations in Australia is now the potential to operate over people. As some in the webinar would be aware, Australia has been reluctant to date to approve operations over and near people. And in most cases, CASA is constrained by regulation from issuing an approval for such operations. The consequence is that BVLOS operators have needed to ensure that they have adequately separated from people when operating BVLOS. And this has significantly reduced the ability to conduct BVLOS operations outside of controlled ground areas, even where there is an extremely low population density. To date, only one operator in Australia has been approved for routine overflight of people when operating a BVLOS. And of course, I'm referring to the delivery operations conducted by Wing, who has, at least in Australia, lent heavily into the SORA methodology, both as an operator and as a contributor. The good news is, CASA recently published a management instruction relating to operations over and near people. After extensive research and analytics, CASA has determined that certain SORA compliant operations meet an acceptable level of safety for operations over people, and that operators who fulfill the requirements will be permitted to operate over people when conducting both VLOS and BVLOS operations. And there's further details of that available on the CASA website. I'd be remiss in talking about BVLOS in Australia if I didn't mention EVLOS. In 2020, CASA created a framework for streamlined approval of operations outside of VLOS, where trained observers were used to provide situational awareness of the pilots. This framework doesn't involve SORA. It's actually slightly outside of the construct of Visual Observer and SORA. And it's built in a way to enable certified operators to gain Australia-wide standing approvals for the conduct of these types of operations. Over the past few years, these operations have become commonplace, and CASA continues to review the framework to see how it can be used to better enable industry while maintaining the required level of aviation safety. That brings us to the end of the presentation. I encourage questions through the Q&A session. And again, thank everyone for attending.
Thanks very much. I'm just waiting for Jackie to turn on my camera, and I'd also like the panelists to please turn on their cameras, because we're going to open to questions. Thanks. Thank you very much to all the presenters, and I'd just like to give a quick introduction to Selena. If you could turn on your, there we go. Selena, could you just introduce yourself as a panelist, please?
Sure. Hi everyone. As I said, I'm Associate Dean in the School of Engineering and specifically in the School of Aviation Aerospace at RMIT University. Particular interest in RPAS. I was also at CASA for 10 years doing a lot of work with drones and the initial regulation setup before coming over to the academic side. So I'm a drone pilot, and we do a lot of research, and my background is safety management systems and human factors teaching at university. So I was really happy to hear what Kyle was saying about the human factors challenges. So I'm happy to have questions about those topics if anyone has them.
Thank you very much, Selena. The first question came in via the registration process, and that was a person who I'm not quite sure who it came from, who said they're very interested in drones for healthcare. The issues around using drones in the delivery of health, as in health medications, as well as potentially health services. I'd like to open that up to the panel as a whole. When you have a specific use case like health, where drones could potentially be carrying highly scheduled and Schedule 4, Schedule 8 drugs, how does that increase the risk, not necessarily related to the drone itself, but as mentioned by one of our presenters, the human factors, in the utilization of what the drones deliver? I'm going to open it up to the panel as a question.
I'm happy to start it off, Leanne. I think it's an excellent opportunity, first of all, for remote and regional landscapes like Australia and the US. So we have a lot of remote populations, and we're very interested in research studies looking at the delivery of things like medications to these remote communities. But as you say, in addition to the regular risk management with operating the drones, it's the community acceptance that's a really big risk to manage, not just the people they're flying over, but if they're bringing materials into their community and they don't know what an RPAS is or what the risk around it is, in some situations they just don't want it to come anywhere near them. They might want to knock it down. So we need to really work on that education piece before it's actually even accepted, I think, to communities.
Absolutely. And I would sort of put it out there, the full supply chain of individuals that will be both sending off that those loads, as well as who's receiving it, is going to be quite important, particularly if they are, Schedule 8 drugs. There's also a training and skills aspect to support different use cases for more broad usage of drones. Thanks, Selena. I've got a question here from Matt Warrad. Sorry for the butchering of your surname. Matt is from the Drone Operations Officer at Charles Darwin University. Why is it that the UAS industry worldwide decided not to use the previous model set by Crude Aviation? That is, you get your pilot's license, then you get aircraft type endorsement, and then you do your IREX/IRA, and you can plan to fly everywhere. If we have rigorous testing requirements, why do we need location-specific risk assessments? So I'd probably hand that over to, depending on if we get an Australian perspective or if we get a USA perspective, I'll hand over to Rowan for an Australian.
Sure. Given that it's an Australian located question, we'll answer that. And it's an exceptionally good question. And to be honest, it's something that we talk about quite a lot in the policy reg team. Looking at, so a lot of our work is, what is the future of regulation in Australia? Where are we going to be in 10, 15, 20 years time? And so it's an exceptionally good question. And I think when you break it down, a lot of it's got to do with the ground risk. We are operating platforms where we don't have certification, we don't have a reliability rate, and so we can't just go and put that aircraft over anyone. There are requirements to keep people on the ground safe, and I think that feeds a lot into it. So it's one thing to be able to operate safely within the airspace system. It's another thing to be able to keep everyone else around that platform safe. And to some degree, that extends to when you can't do detect and avoid, when you can't do VLOS, for instance. It's the most common mitigator we use in aviation is VLOS, but you take VLOS away, it becomes really difficult to create a structure of rules to allow to do that. I suspect that the future will have that, and in fact, I've little doubt that eventually we'll get to the point of having that. But right now, I don't think our platforms are developed enough that we can create a rule set to do it.
Thanks very much. We've got a question from Beck Ludgate. Why can't a SORA be category specific, i.e. less than 25 Ks, VTOL rather than aircraft specific? I'm going to open that to the whole panel.
I'll jump on this one.
Thanks, Lux.
A little bit on a follow on to this goes in line with what Rowan was saying. It's a chicken or the egg problem, right? You don't have the data, you don't have the things you need to regulate. And if you regulate, what are you regulating against? So all these, we're in the World 1 phase of manned aviation where we are today in remote aviation. Aircraft are changing, they have made of different materials and processes. So even just getting a basic model in that small category is extremely difficult. So the concepts, I think, generally with regulators around the globe is let's find ways that our past UAVs will be safe to people on the ground, also to traffic in the air, keep seeing how they perform and then regulate more on that. And I think it's everyone's goal internationally to get as much as possible one set of standards and rules. It's just different areas have different priorities, different nations have different needs, and that's causing the different varieties to happen. With SORA, that's why we reach out across the globe and we're working with different research groups, different regulators to try to pull these things together, like Kyle was talking about, to participate in these standards groups to try to get these things down to one answer. I don't know if that answers it completely, but that's my input.
Yeah,
Thanks.
I might just add something to the end of that. Thanks, Alex. That was great. Realistically, I think that is the progression, and that's why EASA and SORA have, or JARIS have, the ocean specific certified. It's just that we have a specific at the moment, and the back end calculations that actually justify the ground risk model don't lend themselves well for categories. There is sufficient mathematical granularity in it that it needs to be done in that particular way. But as we learn more, we start to put more things into an open category, whether that's the Australian excluded or model system, whether that's a standing approval under a REOC, whether it's an EASA open category. It's about, we learn more, and the exact same thing happened with our VLOS operations. So there was a time in Australia where every single operation needed an approval. And now you can go out and get a sub 2 kilogram aircraft without a pilot's license in Australia and go and operate that commercially. And as the weight increases, the requirements increase, but effectively you want to go and do that as a commercial operator under a remote operator certificate, and it's VLOS, or even in many cases VLOS. Well, you've got a 25, for instance, as a weight break. So we're getting there. It just takes time.
Thanks very much. Oliver Hayes has asked the question, considering the critical nature of emergency response scenarios, such as search and rescue missions, is there any consideration for implementing quicker approval processes for BVLOS operations that might fall outside the traditional specific operations risk assessment SORA framework, similar to the process of mercy flights in crewed aviation in Australia, given the significant potential to positively impact or save lives? I'm going to hand it.
Someone else to take this first if they would like.
I can just talk about from the United States side. There's some precedent for this exact process, and then Rowan, if you want to jump in and provide the more specific context. So we do have procedures for drones of all sizes, and group 1s through 5, so everything up to thousands of pounds, to get access near instantaneously with a 24/7 sort of call center, if you will, through a special government interest process. So That sort of thing exists, but I'm not up to date on the implementation or the ability of the implementation for something similar. But I would just say that it's out there. It exists in our world over here with your not so near neighbors. But Rowan, if you want to talk more specifically about your jurisdiction.
Yeah, we have some nuances in our local legislation about this. So the Civil Aviation Safety Authority is not empowered to reduce the level of safety that we owe people on the ground, for instance, because of some other harm. And so we owe a general responsibility to the Australian people for aviation safety hazards. And we need to minimise those hazards to an appropriate level. And so we run into a situation, a bushfire is a classic example of this, is just because your house is about to be burnt down doesn't necessarily give CASA the authority to reduce the safety standards from an aviation risk perspective to what we owe to you. And so it's a complicated framework that we're working through, and it's something we're in regular discussions with all stakeholders over. But in saying that, there are ways and means to achieve the same outcome. And so we're working a lot with the JARIS PDRA working group under safety risk management. So predefined risk assessments as a methodology to try and have some of these operations go a lot faster through the SORA, so we're not waiting for as long. And the other thing we're doing is encouraging operators who are operating in that sort of environment in the emergency sector to go and get pre-approved for a level of a sail in a particular population density in a particular airspace area. So once we have operators that we are confident that they can operate at that sail level with that type of population density and that type of airspace, then it moves to this new area that you need to do. Does it look like that? And can we start broadening out the areas that we approve to people? Now, we're not there yet, but it's that crawl, walk, run approach. But we're certainly saying for those operators who are in that space, what can you do before there's an emergency so that when there is an emergency, we've already looked at it?
And just to tack on with a little bit more clarity, it's not a free ride for anybody to fly. There is a pre-approval process for the process that I mentioned, similar to what Rowan's talking about.
Thanks very much. I think we've answered all the questions, certainly the ones that I can see. I'd like to take the opportunity to thank Assure and all of the presenters and Rowan and CASA for presenting so fabulously. It's an emerging area, and as we can see, there's a huge amount of research and application of that. We look forward to catching up again and seeing where this is progressing. But I wanted to thank you all for participating and wish you all a very good day or evening, depending on where in the world you are. So thanks very much to everyone for participating and for joining in and presenting.